Sine squared of 3x plus 5 cosine of 3x minus 3 is equal to 0. We're solving for x. So, if you notice, this is a quadratic. So this can be factored. So I'm going to factor this. Okay. Hopefully, it can be factored. Okay. So 2 cosine x. When I multiply those two, I'll get that. Oh, cosine 3x. Phew. Not so easy. I wish it was just cosine x. That would be easy. Okay. So cosine 3x. Alright. So when I multiply those two, I'm going to get that. So I'm looking for factors of 3. Remember, I got to make a 5 in the middle. So I'm going to put 3 over here. I'm going to put 1 there. I'm going to make this into a plus 3 and a minus 1, and that's factored. And once we factor a quadratic, we set each factor equal to 0. I set 2 cosine of 3x minus 1 is equal to 0, and I set cosine of 3x is equal to plus 3 is equal to 0. Okay, plus 3 equal to 0. Okay, let's solve for both of these. Okay, I'm going to have a cosine of 3x is equal to positive 1 over 2. And here I'm going to get cosine of 3x is equal to negative 3. Alright, I can trash that because the least the cosine is going to be is negative 1. So I get nothing from that. So what's left is cosine 3x is equal to 1/2. Actually, this isn't that bad. Okay, because if they gave me domain restriction, yeah, they do give me domain restriction. Okay, so it is bad. Okay, let's go ahead and do this. 0 to 2 pi. I notice I have a domain restriction up there on the top. Okay. Now, in that box, okay, where is cosine? Cosine of what's going to give me 1/2? Well, cosine right there is going to be 1/2 because that's 1/2, and that's going to be pi over 3. And positive 1/2 is also down here. Okay, and I can call this also negative pi over 3. Okay, I can use plus pi over 3 and minus pi over 3. I can also use, instead of using negative pi over 3, I could use 5 pi over 3. But let's just use plus and a minus pi over 3. So that means inside the box, that could either equal to pi over 3, or it could equal to negative pi over 3. Okay, so what is my box? My box is 3x. That's equal to pi over 3 plus or minus 2n pi. And my n is equal to 0, 1, 2, dot, 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 dot. I'm solving for x, so I had to divide by 3. X is equal to pi over 9 plus or minus 2n pi over 3. Alright, so I have to do it for this one here also. I'm going to set my 3x is equal to negative pi over 3 plus or minus 2n pi. Okay, divide by 3. X is equal to negative pi over 9 plus or minus 2n pi over 3. Alright, I'm all set up. Now, if I didn't have this domain restriction that I have here, if I didn't have that, I would be done. Okay, but I have that. So I have to now plug in the values. N is equal to 1, n is equal to 2, so on and so forth. So let's work on this and let my n is equal to 1. Or n is equal to 0. When I put 0 for the n, I get x is equal to pi over 9 plus 0, and which is inside my domain 0 to 2 pi. Okay, one of the nice things about this is, notice it's going to just 0 to 2 pi, so I don't have to worry about the minus part. So I can actually go over here, and let's go ahead and take care of that right now. Let's erase the minus part, because I'm just going to go in the positive direction. Okay, so that's, at least that's one thing nice. Now if I went from negative 2 pi to 2 pi, yeah, I have to worry about the negative part. Right, then I'm going to let my n is equal to 1. So I get x is equal to pi over 9 plus, okay, 2 times 1, which is 2 pi over 3. Alright? Common denominator is 9, so this now, when I multiply top and bottom by 3, I'm going to get pi over 9 plus 6 pi over 9, which is going to give me a total of 7 pi over 9. Okay, that's less than 2 pi, so I hold on to that. Okay, right, now I'm going to let my n equal to, n is equal to 2. So I'm going to get x is equal to pi over 9, okay, plus 2 times 2 is 4, so it'll be 4 pi over 9. Okay, 4 pi over 3. Common denominator is 9, so I had to multiply top and bottom by 3, which is going to give me pi over 9 plus 12 pi over 9, which is going to give me 13 pi over 9. Okay, I keep that because that's less than 2 pi. Right, now I'm going to use n is equal to 3. N is equal to 3. Okay, so when I put 3 right there, that's going to give me 6. Okay, pi over 3. So I have my n is equal to 3. I'm going to get x is equal to pi over 9 plus 6 pi over 3. Multiply top and bottom by 3 to get the common denominator. So this is going to give me 19. This is 18 here. When I multiply by 3, 18 plus 1 is 19 pi over 9. And that's more than 2 pi, so I stop right there. So I don't go to n is equal to 3. Okay, so I found 1, 2, and 3, and that's only with the first part. So I have a second part I need to work with, and which is over here. So I am going to do the same thing right there. So I'm going to start with n is equal to 0. So I get x is equal to negative pi over 9, okay, plus 0. The negative, I'm only going the positive direction, so I can't use that. So I'm going to let my n is equal to 1. Okay? So I'm going to get x is equal to pi, negative pi over 9. Okay? And then when I put 1 there, because I'm only going the positive direction, so I can also ignore the negative direction on this. So let's go ahead and erase that from that too. So that way it won't be confusing. Okay? So now I have a plus 2 pi over 3. Common denominators, and this is x is equal to negative pi over 9 plus 6 pi over 9, and that's going to give me x is equal to 5 pi over 9, and there it is. That's one more. Okay, now I'm going to let my n is equal to 2. N is equal to 2. So I'm going to get x is equal to negative pi over 9 plus 4 pi over 3. But when I multiply top and bottom by 3, that now turns into 12. 12 pi minus pi is going to give me 11 pi. So x is equal to 11 pi over 9. And that's still less than 2 pi, so I keep that. Then finally, I'm going to let my n is equal to 3. And I'm going to get one more. Okay. And when I do that, I get x is equal to negative pi over 9. Okay. Putting 3 right there will turn into 6. Okay. So plus 6 pi over 3. Okay. And then multiplying that by 3, that turns into 18. Okay. And that's 18 minus 1, which will give me 17. X is equal to 17 pi over 9. Okay, and then when I put n is equal to 4, okay, I'm not going to get anything that's going to be beyond my domain restrictions. So here are my solutions. Okay, let me erase some of this stuff here, and then I can write out all my solutions. So how many places does that cross 0 axis? Because that's what it means when it's equal to 0. So here's my solutions, and I get x is equal to, okay, let's write this out, x is equal to pi over 9, okay, which is that, and then I got 7 pi over 9, and then I have 13 pi over 9, and then I have n is equal to 1, which is going to give me 5 pi over 9 right there. 5 pi over 9, okay, and then I also have 11 pi over 9, 11 pi over 9, and then finally I have 17 pi over 9. Okay, so that's it. Erase that a little bit here, and I can finish that off, and that's basically it. 6 solutions, and there it is. Alright, good thing is you don't have to do it tomorrow. You just need to copy this down. Okay, I'm going to do one more. Like I said, I'll pick a hard one, so I'll do 22. Okay, 3 sine of x is equal to 1 plus cosine of 2x. Alright, now I can't have cosine and sine, so I have to use a trig identity. There's a trig identity for that, and that is 1 minus 2 sine squared x. That's what I'm going to use because I want to have everything in terms of sine. So when I replace that, I get 3 times sine of x is equal to 1 plus 1 minus 2 sine squared x. Right, this is a quadratic, so let's take everything to one side. So I get a 2 sine squared x, okay, plus 3 sine of x, and 1 plus 1 is 2. Take it over the other side, it becomes negative 2 is equal to 0. It's a quadratic. Hopefully I can factor this, and I think I can. If you can't, we'll have to go to quadratic formula. Okay, so it'll be 2 sine x times sine x will give me that, and then factors of 2, 2 and 1. I'll put 2 here and 1 there, make that into a plus, make that into a minus. Okay, this isn't that bad. And do we have a domain restriction on this? And the domain restriction is from 0 to 2 pi. Okay, the reason this is not bad is because notice I just have an x. I don't have like 3x like I had in the last problem. Okay, so this isn't that bad. So I'm going to get 2 sine x minus 1 is equal to 0, and I set sine x plus 2 is equal to 0. When I solve this one, I get sine x is equal to negative 2, which is nonsense, okay, because the least it can be is negative 1. And when I solve this one, I get sine x is equal to positive 1 over 2, which I can find. Now, I don't have to go 2 pi n or 2n pi anymore because this is just x. So I can just go ahead and find that unit circle. Okay, where is sine x is equal to pi halves, or 1 over 2, which is right there, which is pi over 6. Okay, that's 1 over 2 right there. That's going to be the 1/2. Okay, it's also going to be here, okay, which is 5 pi over 6. That's going to be 1/2. And nowhere else is going to be positive 1/2. So I get two solutions. X is equal to pi sixth and 5 pi sixth. So the hardest part of this problem was remembering the trig identity. Okay, remember everything has to be in terms of sine or cosine. You can't have apples and oranges. You either have to have all apples